Okay, so we're going to finish the properties of exponents, and then we're going to do scientific notation. How many have had scientific notation before? Probably everybody, right? Sure. So, quiet, please. You know, get it? We don't use scientific notation a ton in math. I think in science you're going to encounter it more often, maybe than in a math class. But the science teachers kind of expect that you learned about it already. Scientific notation, things like in chemistry, which you guys are a little bit young, but you get things like Avogadro's number, which is like 6.22 times 10 to the 26 or something like that, right? I mean, you're not going to write that out, so you got to use scientific notation. Okay, so now first we're going to go over the last properties. It was the block you copied from page 503. So you've already copied these properties. But just to explain, if you divide something by itself, it's always 1, right? Anything divided by itself. How many times does something go into itself? 1, right? So whether it's 2 over 2, x over x, x to the third over x to the third, it's always 1. But we have a property from the last lesson which says that when you are dividing the same base with exponents, you subtract, right? So that would make this x to the 3 minus 3 or x to the 0, which means anything to the 0 power equals 1, right? Because this is 1. So anything to the 0 power equals 1. That's a property. And you'll confuse it. You'll don't want that. Edit, undo. Edit, undo. Blue. That should be right. Equals 1. You'll want to say it's x to the 1 or something like that, but it's not. It's the number 1. But a lot of times when you see problems like this, they might use some ridiculous number like pi to the 0. Right? You're saying, what the heck could that be? But it doesn't matter what it is. It's 1, right? So that's a property. So that's the property. A to the 0 equals 1. A does not equal 0 because that would be the one exception, right? You can multiply 0 together any number of times, right? It's always going to be 0. And this was the example that you copied. 5 to the 0 is 1. Okay. All right. Do I not have another in between? It's not. So here's another property, or just the explanation of it, right? We did in our previous property when we were showing subtraction, we did x to the 5th over x squared. Here I'm doing x squared over x to the 5th, right? I know from the last lesson that would be x to the 2 minus 5, which is negative 3, right? But actually, if I write them out like 2 x's in the numerator, 5 x's in the denominator, cancel the common factors, what I'm left with is 3 x's in the denominator, right? Which is 1 over x to the 3rd. So what that tells us is it's the same thing if I have x to the negative 3 or 1 over x to the positive 3. Yeah. 2 minus 5 is negative 3, right? And here, right? If I have 2 x's in the numerator and 5 x's in the denominator and I cancel the common factors, what's left? 3 x's in the denominator, right? It's 1 over x times x times x, which is 1 over x to the positive 3. So we started at the same place, but what we ended up with, in one of them we got x to the negative 3, and the other we got 1 over x to the positive 3. Okay? So that leads to a property, which is, it's kind of got 2 parts to it. A to the negative n equals 1 over a to the positive n. right? If you got a negative exponent, the way you get rid of it, and you're almost always asked to not use negative exponents, is you flip it to the other side of the fraction, right? This is what you copied when you did the examples, right? 2 to the negative 1 is 1 over 2 to the 1. Or if you start with a, oh, I wrote that one wrong. Sorry about that. Just confusing that with sequences. Not good. Right, that should have been a to the positive n equals 1 over a to the negative n. So the main thing is if it's negative in the denominator, then you can flip it and it's positive. If it's negative in the numerator, you can flip it and then it's positive. Right? 2 to the first is 1 over 2 to the negative 1. Right? Flipping it to the other side of the fraction makes the exponent the opposite sign. So let's do these three. Then what would 3 to the negative 2 be? How would I simplify it to get rid of the negative exponent? Say again? You flip it. Okay, what would that look like? 1 over 3 to the positive 2, right? Which, by the way, is 1 over 9. How about negative 7 to the 0? Right? By the property, it's 1. About 1/5 to the negative 2. Say again? Okay, so if you're thinking of like what we did, right, you could say, well, wouldn't that be 1 over 1/5 to the positive 2, right? Yes, it would be. But you could also do it like this. You know, use the property that we had last class, which is when you've got an exponent which is outside parentheses, you can move it in on everything that's inside, right? So that could be 1 to the negative 2 over 5 to the negative 2. Okay. And then simplify. How do I make that 1 to the negative 2 have a positive exponent? I put it to the bottom. And how do I make that 1 over 5 to the negative 2 have a positive exponent? Put it to the top, right? And so that is 5 squared, 25. Which is the same thing as this here, right? If I simplify, this would be 1 over 25, right? But remember, when you divide by a fraction, that's like multiplying by the reciprocal. So in either case, it's 25. And usually the way you could deal with that is just, if you have a fraction which is raised to a negative exponent, then just flip it. And then it's positive. Just move each one, move the numerator to the denominator, denominator to the numerator, and that'll switch that to a positive. Okay. Okay, try these 4. So what's the first one? 1, right? How about the next one? 1 over 64, right? If you take it as the first step would be 1 over negative 8 to the positive 2, and then what is that? That's 1 over 64. How about the next one? Right, flip it. And what about the last one? 1. So these are all the properties that we did. These are all the properties of exponents. And counting this one, the last one, as just being 1, right, with that you flip from the numerator to the denominator, or from the denominator to the numerator. That's 7 properties. And you don't get this. You get a little bit of a review of this in Algebra 2, but for the most part, you're just kind of expected to know these properties. We'll use some of them, especially the first couple we'll be using when we get to polynomials, which is next, because we'll have to multiply things. Okay. So now, evaluate and simplify. When it says evaluate, I mean, you are going to find the number that it equals. Okay. So how about the first one? Which property would I use? Add the exponents, right? Okay, well, what would you get? 6 to the 0, which is 1. Okay, which property would you use on the next one? Negative 4 to the negative 2 squared. Multiply, right? So that would be 4 to the negative 4, right? How do you simplify that? You make it 1 over 4 to the positive 4. And then that you can figure out. 16 times 16. 4 times 4 times 4 times 4 is 256. Right? What about 1 over 3 to the negative 4? 3 to the positive 4, which is? Aiden, settle down. Right? 3 times 3 is 9, so 9 times 9 is 81. Evaluate and simplify. How about that one? Which property would you use? Subtract. Okay, what would you get? Yeah, 5 to the negative 3. Okay, but then you have to simplify that. Flip it. Right, and then 5 to the third, you can figure. 5 times 5 times 5. So you try. There's 4 of them there. Try to evaluate and simplify using the properties. So what do you get in the 1 over 4 to the negative 3? Should have been 64, right? First you flip it, and then you simplify, 64. How about the negative 3 to the 5th times negative 3 to the negative 5th? Okay, properties of exponent says you add it up, and you get 0, and that is 1. How about 5 to the negative 3 to the negative 1? What do you do with these exponents? Multiply. That's 5 to the positive 3, which is 125. And 6 to the negative 2 divided by 6 squared. What's the property you're going to use? Okay, well, if you subtract negative 2 minus 2, what do you get? Negative 4. Right. 6. Remember, it wouldn't be 1. It would have to be 6 to the negative 2 over 6 to the negative 2 for that to equal 1. So it's not that. Okay. Negative 4, which is 1 over 6 to the positive 4. Yeah. 1, 2, 9, 6. So don't, as I saw one person do, like take this and then move it into the numerator again, right? That's 1 divided by, so it's still got to be 1 divided by. It stays in the denominator. Okay. So simplify. and use only positive exponents in the answer. These problems, almost always that's what it says, right? That's why they give us that last property of flipping, right? So what property would I use to deal with the 3, which is outside parentheses? Distribute it, right? Distribute it to all the factors inside. Don't forget the 2, right? So that's 2 to the third, x to the third, y to the negative 5th to the third. Okay, now 2 to the third we can figure, right? 2 times 2 times 2 is 8. X to the third stays the same. Then what do you do with the y to the negative 5th to the third? Multiply. Okay, then it's, at this point, unless they had that last statement, right, you'd probably stop. But it says use only positive exponents. So how do I get rid of the y to the negative 15? 8x to the third stays in the numerator, and the y only goes to the denominator, and now it has a positive exponent. Done. A lot of times students want to flip something else, not just the thing that's got a negative exponent. Remember, it's only that factor which is going to get flipped. These have positive exponents. They stay where they're at. Yeah. Same thing, right? She's saying, what if you wrote it like this? 8x to the third times 1 over y to the 15th. That's fine. It's the same thing. Okay, how about this one? There's a lot of simplifying to do here. What do you think would be the first thing we need to do to simplify? In a order of operations kind of way, PEMDAS, we probably need to deal with those parentheses first. Parentheses and exponents, right? Because these things are always going to have exponents. All right, so let's deal, what are we going to do? 2x to the negative 2. So we should distribute the negative 2, right? Be systematic about it. Don't look at something like that and just say, I can't do it. Do the first thing. Everything counts for a little. That's 2 to the negative 2, x to the negative 2, right? Okay, everything else we're going to leave the same for now. Okay, what do you think we can do next? Can you add exponents? Can you add these exponents? No, they have different bases. Yeah, I mean, you could take the x to the negative 2 over x squared, right, and subtract, right? Same thing here. So you can do with that. And then what about this 2 to the negative 2? Make that a 1 over 2 squared, right? So each one, so dealing with the numbers here, the first part of it is going to be 1 over 2 squared times negative 4. That's just keeping the numbers together. When dealing with the x's, that's x to the negative 2 over x squared, which would be x to the negative 4. And y to the 5th over y squared is y to the 3rd. Okay, we still got a couple things we need to simplify. Take this 2 to the negative 2, because there's a negative exponent, and flip it to the denominator, and now it has a positive 2. Right, and then the negative 4 was already there. Right, the negative 2 minus 2 is negative 4, and 5 minus 2 is 3. So what is 1 over 2 squared times negative 4? Okay, it's like negative 1/16, right? 2 squared is 4 times 4 is 16. It's got a negative on it. How about the x to the negative 4? put it in the denominator. Now it's got a positive 4. And then y to the third was okay. And then let's just put it all together. Negative y to the third over 16x to the fourth. Okay, must be something coming. All right, try to simplify that one. Yeah. What did you do here? Why does it have a 3 to the negative 3? There's no parentheses. You're making things up now. There's no parentheses. It's only on the y. Okay. Oh, really? Let me see this.
I don't think I did well.
How do you get a 1/2 out of that? Yeah. And do you have an answer? Let's see. For all the world to see. 1 over 3 x squared y to the fourth, all in the denominator. Looks good. Again, it's probably... Quiet, please. Let's go over. It's probably good to like deal with the numbers and then the x's and then the y's, right? The 3 over 9 is 1/3, right? Sometimes students will take that because they're like looking at the x's and the y's and thinking about subtracting exponents, and they'll think they're going to subtract 3 minus 9. But remember, 3 over 9 is just a fraction, right? We just deal with it like a fraction. So that'll give us the 1/3 from the numbers. Okay, x divided by x to the third. So if you subtract, remember, there's a 1 here, so that's x to the negative 2. And then negative 3 minus 1. Y to the negative 4. Okay, but we don't want to have negative exponents, so we will... 3x squared. Y to the fourth. And don't think like there's something the matter with like you're moving everything to the denominator, like there's nothing left in the numerator. There's a 1 in the numerator, right? Okay. I think we'll move on to scientific notation. Yay, yay. You love scientific notation? Oh my gosh. Okay, so scientific notation is a different way to write really large or really small numbers. Okay, and these are just a couple examples. This is what we're going to call the standard form when it's not in scientific notation, and then this will be the scientific notation. So notice here, 2 million, right, equals 2 times 10 to the 6th. So how does the 2 million turn into a 2? Drew? Okay, the decimal point was here. So we moved the decimal place over how many places? 1, 2, 3, 4, 5, 6. So, you know, when you move the decimal place over to the left, the number is getting smaller, right? So if the 2 million becoming a 2 is getting smaller, then that is getting bigger. So it goes from to 10 to the 6th, right? So that means move the decimal place over and there's a number. That's generally the way they do that, right? So this is 2 between 1 and 10, and times 10 to the 6th. All right. Or if you move the decimal, like 0.005 becomes 5 times 10 to the negative 3 by moving the decimal place over to the right, right? Once, twice, 3 times. So as you move to the right, this number is getting bigger, right? 0.05, 0.005. to 0.0005 to 0.5 and finally to 5. So as that number gets bigger, that number gets smaller, -3. It goes down. I mean, you could say it like this, right? This 2 million right here, that's times 10 to the 0. And this is times 10 to the 0. Because what is 10 to the 0? It's just 1, right? So again, if I move the decimal place of 2 million over 6, that makes the 2 million to 2. That makes that part of it smaller. So then you increase the 0 to a positive 6. So if I move the decimal place over to the right to make 0.005 into a bigger number, 5, then I got to go down 0 to -3. Right? That's the principle of scientific notation. So let's write these in scientific notation. Right. How many decimal places am I going to have to move for this 42,590,000? Okay. It looks like to go from here to here is going to be 7. 7 to the left. Right. So what is the number now? 4.25. Well, I'll include the 9 times 10 to the positive 7, right?
How do you know how many? Oh, never mind.
So we're always moving the decimal place over, so it's like the second to the last. We've got to leave one number to the left of the decimal place. So that's how we're going from here over 1, 2, 3, 4, 5, 6, 7. Okay, how about the bottom one? How many decimal places are you going to move that? So 1, 2, 3, 4, 5, right? So that'll be 5.74 times 10 to the 1, 2, 3, 4, 5, right? That's that way 5 places. -5. Now, before we had calculators to do all this stuff, if I had to do math that involved numbers like this, then I would, in scientific notation, I would multiply these two together, right? And, you know, how do we do that? I mean, those days before calculators, we had slide rules. And a slide rule, which I don't think I have a slide rule with me today. I had my dad's slide rule because he was an engineer in days when they didn't have calculators. You did it on a slide rule. People who knew how to use them could do it really quickly, really accurately. They could get this part, right? And then they would use properties of exponents to add, right? So whatever this is, it looks like it'll be about 20-something, right? 20-something times 10 to the second, 7 plus -5. Right? What is 5.259 times 5.74? Put that in. Just to show, because this is why we use scientific notation in the old days. 5.259 times 5.74. 24.4. I'll just say 24.4, okay? Times, and then I would add the exponent, 7 plus -5, and I would get 2, right? But usually we don't want this to be 2 places over. We want this to be 1 over. So if I move this over to the left 1, what will I do to that? Add 1, right? As this number gets smaller, that number gets bigger. So it becomes 2.44 times 10 to the third. Okay, do that one. Okay, time's up. Hurry up. So the first part of it is kind of decided. It's going to be 5.39. The only question is, how many places over did you move to go 5 to the left, right? So that makes positive 5. Okay, now let's do the opposite. Let's take something that's in scientific notation form and write it into the standard form. So I'm going to be moving the decimal place, right? And losing the 10 to the 6th. How many places should I move to which direction?
To the right.
Okay, so I should be moving that direction with the decimal point 6 spaces, right? Right, so that'll be 2 and 1, 2, 3, 4, 5, 6. Is that right? 1, 2, 3, 4, 5, 6. Okay. So what is that number?
2,007,500.
Okay, how about 1.685 times 10 to the negative 4? Which direction am I going to move the decimal place? The decimal point. I'm going to move it that way, right? So how many zeros do I need to put in front of that? 1, 2, 3. Okay? So do that one. Write it in standard form. Right? What is it? 0045. Right? Evaluate. Write your answer in scientific notation. So first, we're going to multiply 8.5 times 1.7. Somebody do that one. What is 8.5 times 1.7? 14.45. Okay, and then what will be the power of 10? It's 10 squared times 10 to the 6th. What do we do with the exponents? You add them. So that's times 10 to the 8th. Right, and now to get our mantissa, what's called the first number, to be between 1 and 10, I need to move the decimal place over. Okay, so if I move this over to make it 1.445, what does that do to the exponent? It goes up, right? I made that 14 smaller by making it 1.4, so I have to make the exponent bigger. Okay, evaluate. So, I mean, this really comes down to the properties of exponents. What do we do when we have a power outside parentheses? You distribute it, right? You distribute it. So this has got to go on the 1.5, and it's got to go on the 10 to the negative 3. So this is 1.5 squared times 10 to the negative 3 squared. Now 1.5 squared, 2.25, right? And then what is 10 to the negative 3 squared? Multiply exponents, 10 to the negative 6. There. That's the answer. That's a good question. I don't know who started doing that. Yeah. Okay. So divide, right? So divide the first number. What's 1.2 divided by 1.6? Okay, now what are you going to do with the exponents? What is 10 to the fourth over 10 to the negative third? 4 minus negative 3 is plus 3, so it's 7. Minus a negative makes positive, right? Makes a plus. Okay, but now we need to have that first number between 1 and 10, right? So I'm going to move the decimal place over to make it 7.5 instead. And what do I do with the exponent? Yes, as 0.75 got bigger, then the exponent's got to get smaller. 6. Okay, try those two. And that's the last slide. Okay, good to go? So that was it. Let's see, what is today? Today's Wednesday? Okay. So our quiz is like 2 classes, not next time. Yeah. You got an hour to do it, so. Oh, come on. It's easy stuff. I'll bet you'll be done. You'll be done before the date of the block's out. You got how much?
60 minus 8.